March 2nd, 1943, Dobodura Airfield, New Guinea. Technical Sergeant Paul "Pappy" Gunn knelt beside the nose of a North American B-25 C. Mitchell bomber, his calloused hands running along the aluminum skin where the bombardier's greenhouse should have been. Instead of transparent plexiglass, solid metal plates covered the opening, broken only by 8 menacing black holes that housed .50 caliber machine guns. The modification violated every Army Air Force's regulation, defied manufacturer specifications, and represented the unauthorized work of a man driven by grief, rage, and an engineer's obsession with destruction. What Japanese naval commanders didn't know as they prepared their massive convoy for the final push to reinforce Leh was that Gunn's forbidden modifications had transformed the B-25 Mitchell from a medium bomber into the most devastating anti-shipping weapon in the Pacific theater. Within 72 hours, these modified aircraft would shatter Japanese naval power in the Bismarck Sea and prove that sometimes desperation creates innovation that doctrine never imagined possible. The transformation had begun 18 months earlier when Pappy Gunn received news that would drive him to revolutionize aerial warfare. His wife and 4 children, trapped in the Philippines when the Japanese invaded, were missing and presumed captured. The 42-year-old former Navy pilot and Philippine Airlines mechanic had escaped to Australia with nothing but his engineering skills and a burning need for revenge. When the Army Air Forces offered him a position maintaining B-25 bombers, Gunn saw an opportunity to turn his mechanical genius toward killing the enemy that had destroyed his family. The North American B-25 Mitchell represented American industrial capability at its wartime peak. The twin-engine bomber featured 2 Wright-R 2600 Cyclone engines producing 1,700 horsepower each, sufficient to carry a 3,000-pound bomb load over 1,350 miles at 272 miles per hour maximum speed. The standard armament included a 75mm nose gun in some variants, plus defensive machine guns in dorsal and tail positions. It was a competent medium bomber, but Gunn saw something more lethal lurking within its aluminum frame. The problem with conventional bombing against shipping targets was accuracy. High-level attacks achieved hit rates below 10% against maneuvering vessels, while the bombs that did hit often failed to penetrate armored decks or vital spaces. Low-level attacks improved accuracy but exposed aircraft to devastating anti-aircraft fire from ship-based weapons. Gunn's solution was characteristically direct. If you couldn't hit them from high altitude, get close enough to guarantee hits while carrying enough firepower to ensure destruction. Colonel Lyndon Johnson, commanding the 42nd Bombardment Squadron, had initially resisted Gunn's modification proposals. The technical sergeant was requesting permission to remove bombardier equipment, install forward-firing machine guns, and fundamentally alter the aircraft's center of gravity and performance characteristics. The modifications violated maintenance protocols, warranty agreements, and operational doctrine. But combat results spoke louder than regulations, and Johnson gave Gunn permission to experiment with 2 aircraft. The engineering challenges were formidable. Installing 8.50 caliber machine guns in the nose required structural modifications that could compromise the aircraft's integrity. The ammunition feed systems needed to function reliably under combat maneuvering, while providing sufficient ammunition for sustained engagements. Electrical systems had to power gun synchronization and firing controls without overloading the aircraft's generators. Most critically, the modifications had to be accomplished using only materials and tools available at forward airfields. Gunn's solution demonstrated the improvisation skills that made American maintenance crews legendary throughout the war. He salvaged machine guns from crashed aircraft, fabricated mounting brackets from aluminum stock, and created ammunition feed systems using parts from multiple sources. The electrical modifications were accomplished using wire and components stripped from other systems. The nose armament was arranged in 2 rows of 4 guns each, creating a concentration of firepower that could destroy any vessel caught in its path. The first test flights revealed both the potential and the problems of guns' modifications. The forward-firing armament provided devastating firepower, but the aircraft's handling characteristics were significantly altered. The nose-heavy configuration required constant trim adjustments, while the increased weight reduced range and ceiling. Most troubling, the structural modifications created stress concentrations that could lead to catastrophic failure under high-G maneuvering. Gun addressed these problems through iterative modifications that refined the design without compromising its lethality. Weight distribution was improved by relocating equipment and removing unnecessary items. Structural reinforcements were added at critical stress points, using materials salvaged from aircraft beyond repair. Flight characteristics were improved through control surface adjustments and trim tab modifications. Each change was tested under increasingly demanding conditions until the modified aircraft could perform reliably in combat. The tactical doctrine for employing the modified B-25s evolved through trial and error as crews learned to exploit their aircraft's unique capabilities. Traditional medium bomber formations were useless for the modified aircraft, which required different approach angles, release points, and defensive patterns. Gun worked with experienced pilots to develop attack profiles that maximized the gun's effectiveness while minimizing exposure to defensive fire. The key innovation was skip bombing, a technique that combined low-level approach with delayed fuse bombs that would skip across the water like stones before striking ship hulls below the waterline. Combined with the devastating forward-firing armament, this technique could disable ship defenses before delivering the killing blow with bombs that penetrated the most vulnerable parts of the hull. The modified B-25s could approach at wave-top height, rake enemy vessels with machine gun fire, skip bombs into their hulls, and escape before defensive fire could respond effectively. Training for these missions required pilots to master flying techniques that pushed both aircraft and crew to their limits. Wave-top flying demanded split-second reactions and absolute precision, as the margin between effective altitude and fatal impact was measured in feet. Skip bombing required precise speed and angle calculations to ensure bombs struck their targets rather than bouncing harmlessly over them or exploding prematurely. Gunnery training focused on engaging multiple targets in rapid succession while maneuvering at high speed and low altitude. The psychological pressure on air crews was immense. Unlike high-altitude bombing, where targets appeared as abstract shapes on the ground, skip bombing brought crews close enough to see individual enemy sailors and witness the direct results of their attacks. The modified B-25s flew through defensive fire that could be heard impacting the aircraft, while their own weapons generated smoke and noise that filled the cockpit with the sounds and smells of combat. Japanese naval intelligence had detected reports of modified American bombers through intercepted communications and survivor accounts, but dismissed these as tactical rumors or misidentified conventional attacks. Their defensive doctrine assumed American bombers would attack from medium or high altitude using conventional bombing techniques. Anti-aircraft weapons were positioned and trained for high-angle fire, while damage control procedures focused on bomb hits rather than machine gun attacks that could disable defensive systems. The strategic situation in March 1943 provided the perfect testing ground for guns modifications. Japanese forces in New Guinea were critically short of supplies, ammunition, and reinforcements as Allied pressure mounted throughout the theatre. The decision to run a major convoy from Rabaul to Leh represented a desperate gamble that could either resupply Japanese forces or result in catastrophic losses that would end their ability to resist in the region. Operation 81, as the Japanese coded their convoy mission, involved 8 destroyers and 8 transports carrying 6,900 troops and vital supplies. The convoy was protected by fighter aircraft from Rabaul and intermediate bases, while routing was planned to minimize exposure to Allied air attacks. Japanese planners assumed that conventional Allied bombing would achieve historical hit rates of less than 10%, making the convoy's arrival probable despite expected losses. Admiral Kimura Masatomi, commanding the convoy, had studied Allied bombing patterns and defensive techniques throughout his career. His ships were equipped with the latest anti-aircraft weapons and manned by experienced crews who had survived previous convoy runs. The formation was designed to provide mutual support while maintaining speed and maneuverability that would complicate Allied bombing runs. Everything indicated a difficult but manageable passage to Leh. What Admiral Kimura couldn't know was that American intelligence had intercepted and decoded Japanese communications detailing the convoy's route, timing, and composition. The modified B-25s were already positioned at forward airfields, their crews briefed on targets and approach routes. The stage was set for the most decisive naval engagement in the Southwest Pacific Theater. March 3rd dawned clear and calm across the Bismarck Sea as Japanese convoy units formed up for their final approach to Leh. The 8 transports loaded with troops and equipment were protected by destroyer escorts positioned to provide maximum anti-aircraft coverage. Combat air patrols from Rabaul-based fighters provided additional protection, while the convoy's speed and routing were calculated to minimize exposure to Allied air attacks. At Dobodura and surrounding airfields, Papigun made final preparations on his modified B-25s. Ammunition was loaded, guns were test-fired, and mechanical systems were checked with the obsessive care of a man who knew that equipment failure meant death for American aircrews. The unauthorized modifications had become the most closely guarded secret in the Southwest Pacific Theater, known only to the crews who flew them and the mechanics who maintained them. Major Ed Lana, commanding the 90th Bombardment Squadron, briefed his pilots on the mission that would validate or condemn months of unauthorized experimentation. The modified B-25s would lead the attack, using their forward-firing armament to suppress defensive fire while delivering skip bombs against the most valuable targets. Conventional bombers would follow with medium-altitude attacks designed to finish damaged vessels and destroy any ships that escaped the initial assault. The attack formation that took off from New Guinea airfields represented the culmination of American tactical innovation and industrial adaptation. 13 modified B-25s, led by conventional bombers and escorted by P-38 Lightning fighters, headed northwest toward the Bismarck Sea. Each modified bomber carried 8 50-caliber machine guns with 350 rounds per gun, plus 4 500-pound bombs with delayed fuses for skip bombing attacks. At 10:15 hours on March 3rd, radar operators aboard the Japanese destroyer Shirayuki detected the incoming American formation at a range of 45 miles. Admiral Kimura immediately ordered increased speed and altered course to complicate Allied bombing runs, while his escorts prepared for anti-aircraft action. Fighter aircraft from Rabaul were vectored toward the contact, but distance and timing would prevent their intervention during the critical attack phase. The Japanese responded according to doctrine developed through extensive combat experience. Anti-aircraft guns trained skyward in anticipation of medium-altitude bombing runs, while ships increased separation to minimize damage from near misses. Damage control parties prepared for conventional bomb impacts, with particular attention to fire suppression and flooding control. The convoy maintained speed and course changes designed to throw off Allied bombing calculations. Major Lana led his modified B-25s in a descent that violated every principle of conventional bombing doctrine. Instead of climbing to safe altitude for bombing runs, the aircraft dropped to wave-top height, where they became invisible to radar and difficult to track visually. The formation spread out to attack multiple targets simultaneously, with each pilot selecting specific vessels for individual attention. The moment of truth for Papigun's forbidden modifications was at hand. At 10:24 hours, the first modified B-25 opened fire on the transport Kyokusei Maru from a range of 800 meters. The 8.50 caliber machine guns fired in devastating synchronization, each weapon producing 750 rounds per minute of armor-piercing and incendiary ammunition. The combined firepower swept across the ship's superstructure like an invisible scythe, destroying anti-aircraft positions, killing gun crews, and starting fires in wooden structures. The effect was beyond anything Japanese defenders had experienced. Previous air attacks involved bombs dropped from altitude, with warnings provided by engine noise and approach angles. The modified B-25s attacked with machine guns that created no warning beyond the sound of their impacts. Ship defenders found themselves under accurate fire from weapons they couldn't see or effectively engage, while the low-flying aircraft presented targets too fast and too close for conventional anti-aircraft techniques. As the first B-25 raked Kyokusei Maru with machine gun fire, it released 4 500-pound bombs with delayed fuses in perfect skip bombing attacks. The bombs struck the water at precisely calculated angles, skipped across the surface like stones, and smashed into the ship's hull below the waterline. The delayed fuses allowed penetration into vital spaces before detonation, creating damage that was both extensive and irreparable. The explosions that followed were catastrophic. 4 500-pound bombs detonating within the ship's hull created massive flooding that overwhelmed damage control capabilities. The machine gun attacks had already disabled many defensive systems and killed personnel needed for emergency procedures. Within minutes, Kyokusei Maru was listing heavily and beginning its death roll as water poured through multiple hull breaches. The attack pattern was repeated throughout the convoy as modified B-25s engaged targets with mechanical precision. Each aircraft selected specific ships for individual attention, using machine gun fire to suppress defenses before delivering skip bombs with devastating accuracy. The Japanese formation, optimized for defense against conventional bombing, proved helpless against attacks that combined the firepower of fighters with the destructive capacity of medium bombers. Transport Teo Maru fell victim to the second modified B-25, piloted by Captain Bill Benn. The aircraft approached from the port quarter, its 8 machine guns creating a cone of destruction that swept across the ship's bridge and anti-aircraft positions. The skip bombing attack that followed placed 3 of 4 bombs into the engine room, creating explosions that stopped the ship dead in the water while massive flooding began dragging it beneath the surface. Destroyer Tokitsukaze, attempting to provide anti-aircraft support for the convoy, found itself targeted by Lieutenant George Mundell's B-25. The warship's anti-aircraft weapons were designed for high-angle fire against conventional bombers, not close-range engagement with aircraft flying at wave-top height. The modified bomber's machine guns destroyed the destroyer's bridge and forward gun mounts before skip bombs penetrated the hull near the ammunition magazines. The resulting explosion was visible from 50 miles away as Tokitsukaze's forward magazine detonated. The destroyer broke in half, with both sections sinking within minutes. The death of an escort vessel designed to protect the convoy demonstrated the complete inadequacy of Japanese defensive measures against guns modified aircraft. Admiral Kimura, observing the destruction from his flagship Shirayuki, understood that his convoy was facing annihilation by weapons that Japanese doctrine had never anticipated. The modified American bombers attacked with accuracy and destructive power that exceeded anything in his experience, while their tactics rendered conventional defensive measures useless. Radio calls for fighter support brought responses that help was en route, but the convoy would be destroyed before assistance could arrive. The statistical progression of destruction confirmed the effectiveness of guns modifications. Within 30 minutes of the first attack, 6 of 8 transports were sinking or disabled. 3 of 8 destroyers had been destroyed or severely damaged. The convoy that had departed Rabaul with confidence in reaching Leh was scattered across miles of ocean, its survivors struggling with damage that eliminated any possibility of completing their mission. Pappy Gunn, monitoring radio communications from Dobodura, received reports of the engagement with grim satisfaction. The unauthorized modifications that had violated regulations and risked court-martial were proving themselves through combat results that exceeded his most optimistic projections. Each enemy ship destroyed was payment toward the debt he owed for his missing family, while the tactical success validated months of dangerous experimentation. The human cost of the engagement was staggering for Japanese forces. The transports carried 6,900 troops desperately needed for the defense of Leh, while the escorts represented irreplaceable naval assets in a theater where Japanese strength was already stretched beyond safe limits. The loss of trained personnel, modern equipment, and strategic supplies would have effects far beyond the immediate tactical situation. Destroyer Aviation, attempting to rescue survivors from sunken transports, came under attack by the final wave of modified B-25s. Captain Robert Strickland's aircraft approached through smoke from burning ships, using the concealment to achieve complete surprise. The machine gun attack disabled the destroyer's anti-aircraft defenses before skip bombs punched holes in the hull that doomed the vessel to join its companions on the ocean floor. The few Japanese aircraft that arrived over the battle area found targets that were already destroyed and American bombers departing at high speed toward their bases. The fighter pilots, trained for conventional air-to-air combat, were unprepared for the tactical situation they encountered. Their late arrival meant they could only observe the destruction rather than prevent it, while their limited fuel prevented effective pursuit of the retiring American formation. By 11:30 hours, the Battle of the Bismarck Sea was effectively over. The Japanese convoy had been annihilated with losses that included all 8 transports and 4 of 8 destroyers. American losses totaled 1 B-25 shot down and several others damaged, while all crews except 1 were recovered safely. The kill ratio approached 100-1 in favor of American forces, demonstrating the revolutionary effectiveness of Gunn's forbidden modifications. The aftermath of the engagement sent shockwaves through both military hierarchies. Japanese Naval Command faced the reality that their convoy system had been neutralized by American innovations they couldn't counter or replicate. The loss of 6,900 troops meant that Leh could not be reinforced, ensuring its eventual capture by Allied forces. The destruction of 4 destroyers further weakened Japanese naval strength in a theater where every vessel was desperately needed. American leadership initially struggled to understand how such decisive results had been achieved by aircraft that should have been moderately effective at best. Investigation revealed the unauthorized modifications that had transformed medium bombers into ship-killing weapons through the mechanical genius of a grief-stricken father. Instead of court-martial proceedings, Pappy Gunn found himself promoted and assigned to modify additional aircraft using techniques proven in combat. The technical analysis of engagement results revealed the mathematical precision with which Gunn's modifications had solved the problems of anti-shipping warfare. The 8.50 caliber machine guns provided sufficient firepower to disable defensive systems and kill personnel needed for damage control. Skip bombing delivered bombs to the most vulnerable parts of ship hulls where they could cause irreparable damage. The combination of suppression and destruction proved impossible for Japanese forces to counter. Production modifications began immediately as higher headquarters recognized the strategic implications of the new weapons. Manufacturing facilities received urgent orders to modify B-25s according to gun specifications, while training programs were established to teach pilots the techniques needed for skip bombing attacks. What had begun as unauthorized field modifications became standard equipment that would be used throughout the Pacific War. The psychological impact on Japanese naval personnel proved as significant as the physical destruction of their ships. Survivors' accounts described attacks by aircraft that could not be engaged effectively, delivering destruction with precision that seemed impossible. The traditional confidence of Japanese naval forces, built through victories against European and American opponents, cracked under the pressure of facing weapons they couldn't understand or counter. Intelligence reports confirmed that Japanese naval strategy was being revised to account for the new American capabilities. Convoy routes were changed to avoid areas where modified bombers might operate, while escort requirements were increased beyond available resources. The modifications forced strategic changes that further weakened Japanese ability to supply their forces throughout the Pacific theater. The broader implications extended beyond immediate tactical considerations. The success of unauthorized modifications demonstrated that innovation could emerge from desperation and grief as effectively as from formal research programs. Papigun's transformation of personal loss into mechanical genius provided a model for adaptation that military organizations struggled to replicate through conventional procedures. Training programs for modified B-25 operations emphasized the precision required for skip bombing while acknowledging the psychological challenges of low-level attacks. Pilots learned to approach targets at altitudes measured in feet rather than hundreds of feet, while maintaining the accuracy needed for successful bomb placement. The margin for error was minimal, requiring skills that exceeded normal training standards. The industrial implications were equally significant. American manufacturing had demonstrated the flexibility to incorporate field modifications into production systems without disrupting established schedules. The capacity to adapt designs based on combat feedback, implement changes rapidly, and maintain quality control throughout the process represented industrial capabilities that Axis powers could not match. Papigun's personal story took on mythical proportions as word of his innovations spread throughout American forces. The technical sergeant who had lost everything in the Philippines had created weapons that were helping to win the war through mechanical skill guided by the desire for revenge. His modifications became symbols of American ingenuity and determination that inspired similar innovations throughout the theater. The strategic consequences of the Bismarck Sea engagement reverberated throughout the Pacific War. Japanese inability to reinforce Leh led to its capture by Allied forces, opening the way for further advances along the New Guinea coast. The destruction of irreplaceable naval assets weakened Japanese defensive capabilities throughout the region. Most importantly, the demonstration of American tactical innovation served notice that technological adaptation was proceeding faster than Japanese countermeasures could develop. By war's end, over 400 B-25s had been modified, according to specifications developed by Papigun in his grief-driven quest for revenge. These aircraft would sink dozens of Japanese ships, destroy hundreds of aircraft on the ground, and provide close support for amphibious operations throughout the Pacific. The unauthorized modifications that had begun in violation of regulations became standard equipment that helped win the war. The human dimension of the story reached its conclusion when Papigun learned that his family had survived Japanese captivity and would be repatriated after the war. The modifications, driven by grief and rage, had achieved their purpose through technical excellence rather than personal revenge. The weapons created to destroy his enemies had helped liberate his loved ones through the broader strategic victory they enabled. Technical Sergeant Paul Papigun retired from military service as a lieutenant colonel, his unauthorized modifications having earned official recognition and permanent incorporation into American tactical doctrine. The desperate father who had channeled his loss into mechanical innovation had created weapons that changed the course of the Pacific War. His legacy lived on in the modified aircraft that proved innovation could emerge from the most personal motivations to achieve strategic results. The Battle of the Bismarck Sea stood as testimony to the power of individual initiative, guided by technical expertise and emotional drive. Pappy Gun's forbidden modifications had solved tactical problems that formal doctrine couldn't address, creating weapons that achieved results beyond official projections. The victory demonstrated that sometimes the most effective innovations emerged not from military planning, but from personal determination, channeled through mechanical genius.